Good evening, everyone. We have a next talk that is on VigNET, an intelligent camera app that assists you in understanding your surroundings by Padmaja Bhagwat and Manisha R. Over to you, Padmaja.
Thank you so much. Helen Keller once said that there is no better way to thank God for your sight than by giving helping hand to someone in the dark. A very pleasant evening to everyone. I'm Padmaja Bhagwat, and I'm super excited to present Project VigNET to you all. Before we get into the talk, here's a small introduction about us. I'm Padmaja Bhagwat, and this is my dear friend Manisha. We both work as data scientists at Glance India. While I work on monetizing the content for Glance, Manisha here works on personalizing the Glance user experience, which, by the way, has 150 million daily active users. So originally, this talk was supposed to be given by both Manisha and I, but unfortunately, she couldn't join us here today. So you see, I now have double the responsibility to make this talk as interesting and fun as possible. And trust me, it's not an easy job to fit into her shoes, but I'll try my best. So let's get into the main part of the talk. First things first, what are we going to learn today? We are going to see how to build an end-to-end deep learning-based application. Particularly, we'll be looking into a visual question answering based application. And this is how the outline of today's talk is going to look like. First, we'll look into the data and model that enabled this application. Then we'll look into how to quickly prototype such deep learning-based application. And the final part would cover how can we productionize these applications by building services on top of your model. Particularly, we'll be looking into front-end service and an API service. With that said, let's dive into the talk. Some of you might be aware that more than 253 million of world's population suffers from visual impairment, which is roughly 1 in 30. For them, simple everyday tasks like locating a matching pair of socks or telling what dollar bill it is can become extremely difficult. Hence, we decided to build a visual question answering based application which can truly transform your visual world into an audible experience. Now, you might be wondering what visual question answering is. Simply put, it's an intelligent camera app which takes image and a question related to that image and gives an answer out. For instance, let's say you're onto your everyday evening walk where you come across this really cute puppy. You take its picture and ask a question like, what is the puppy eating? Now, both these input then go into our VQA model, which gives out an answer saying it's eating stick, or rather playing with stick, right? So that's the goal of today's application that we are going to build, the model which can take both image and a question and give out an answer in the form of audio. So with that goal in mind, let's see how our dataset looks like. We used VQA v2 dataset in order to train our model. This is openly available on visualqa.org. So what this dataset contains is it has 120,000 plus images and 600,000 plus questions. Each image has at least 3 questions associated with it, and every question has 10 ground truth answers. Of course, there can just be one correct answer depending on the context in which the question is asked. You can see on the right that the data set contains a variety of images, including the image of a woman whose mustache is made up of bananas. So it does have very interesting questions like, what is the mustache made up of? What is the color of her eyes? You see, these are not extremely straightforward questions. We want our model to understand and be able to answer in such unusual and ambiguous scenarios as well. And one more thing to note over here is that our dataset contains both image as well as question in the form of text. Hence, we are trying to look for a model which can understand both these modalities, which can understand both vision and language. And yes, that's the mighty Vision and his famous dialogue for all the Marvel fans out there. On that note, I think we are good to look into the model which can understand both vision and language. I present to you the Vision Language Transformer, also known as ViLT. Well, I understand that this entire architecture might look quite intimidating to look at in the beginning, but do not worry. I'll be breaking it down into smaller components, and we'll go over it in detail. So what you need to know over here is that our model is taking both text, which is our question, as well as image as an input. Now, first let's see how the model is processing the input text. So the concept is similar to that of BERT, and some of you might already know that BERT stands for bidirectional encoder representation from transformers. Well, even if you do not know, that's okay, because we'll see how BERT operates. Let's take the very same question that we saw earlier. What is the puppy eating? So what BERT does is it breaks this input sentence into smaller pieces, which we call as tokens. So even when you're teaching a child, you break down complex sentence into smaller ones in order for it to learn, right? Similarly, you break down the complex sentence into smaller tokens. So once you do that, the next step, you will be masking a few words in the input sentence. And then you will be adding some special tokens to it. Here you can see that we have added CLS, which stands for classification, and SEP, which stands for separator, indicating that it's the end of the sentence. So now that we have broken down our input sentence into smaller tokens, we'll then have to convert it into vectors. Why do we have to do that? It's because ultimately we are teaching a machine, and they do not understand anything other than numbers. So once we have vectors out of your tokens, you need to add something called as positional encoding. This positional encoding gives the information about the exact position where the token lies in your input sentence. It's an extremely crucial information which your BERT requires. So now that we have input which captures both content as well as positional information, we then feed it to the transformer encoder. And this is then trained to identify what the masked word is. In our case, the masked word is puppy. Let's see how it is done exactly. So this is how the transformer encoder architecture looks like. It is taking the input text and the positional encoding, and this is passed through series of self-attention layers, which tries to extract as much information as possible from your input data. So with that, it is then sent to the feed-forward layer, which learns to classify what the masked word is. So you see, the model is trying to derive context from the neighboring words. So we know that this kind of BERT-based model is extremely fast and computationally efficient in terms of language models. So why can't we use the very same concept for images? So yeah, Control-C, Control-V, one thing that we are great at doing. So yeah, let's use the very same concept of transformer for our images. And that's how we get vision transformers. So what it does is it takes your input image, breaks it down into smaller pieces, which we call it as patches. These patches then get converted into vectors, and we add positional encoding to it, similar to that of earlier. We send it to the transformer encoder, which is then trained to identify what the input image is. You can see that the transformer encoder looks exactly same as that of before, except that instead of taking the text embedding, it is now taking the patch embedding, which is the vectorized form of your patches combined with the positional encoding. So this idea was introduced in the paper called An Image is Worth 16 × 16 Words by Google. I highly recommend you to go over that paper, because this concept of vision transformer is now revolutionizing the field of computer vision. So we saw how best we can process our input text. We also saw how best we can process our input image. Now let's bring it all together. And that's how we get ViLT basically. So we took the input question, broke it down into smaller pieces or tokens. We get the word embedding out of it. We take the supporting image, break it down into smaller patches, get the patch embedding out of it. Now both this word embedding and patch embedding is sent to the transformer encoder, which is then trained to identify what the masked word is. Here you can see that the model is making use of both text as well as image. It is trying to context using both this information and is trying to identify what the masked word is. Hence, our transformer encoder is kind of acting like a modality interaction layer. Modality, it is combining both the modalities, vision and the language. So now, our entire goal is not to predict the masked world. What we want to do is, we want a model which can answer the question given an image. So you take this pre-trained ViLT model and you fine-tune it further using the V2 dataset that we saw earlier. So when you fine-tune a model, which means you use the same set of weights and you fine-tune it further using the new dataset. So when you fine-tune it further, you get a model which can answer the question given an image. And that is how we build the core part of our application. If it still sounds complicated, then I do have a good news for you. Python provides all these amazing libraries out of the box for you. So if you are onto the latest version of PyTorch, all you need to do is, from transformers, you need to import ViLT processor and ViLT for question answering. The best part is ViLT for question answering is already fine-tuned onto your VQA V2 dataset, so you don't have to do anything extra. You just have to plug it into your code and it is good to be used. Let's see how it's done. So first you need to initialize your processor, and then you need to initialize your model. You send in your raw input image and question to the processor, which converts it into vectors, also known as encoding. This encoding, we then send it through our model, which gives out the probability of answer. Easy, isn't it? That's all there is. I mean, with just these 5 lines of code, your core part of the application is ready, which can be plugged into your application. So one thing that you need to ensure that is you are on the latest version of the Torch and transformers in order to be able to import these libraries. So now the crux of our application is ready. So the next part is how do we quickly prototype it? But before that, the advantage of using such transformer-based model is that it's computationally fast and efficient, and it has high expressive power. You will soon get to know it when I'll be showing the demo. But yeah, the core part of the application is built using the transformer-based model. So the next part is, how can we quickly prototype it? How can we quickly build a web application out of your model? So you might be wondering, why is prototyping so necessary? Why do we have to build a web application? Trust me, it's the most interesting part of building the entire application. So the reason for building a web application is that we as a data scientist are shielded from a lot of real-world requirements. And in order to be able to better communicate with your stakeholders, having a web application helps a lot, instead of showing the code files. So you might again question me, saying that building a web application is not an easy task. And if you're someone like me, for whom dealing with HTML and CSS code is like a nightmare, then Python has a solution for that as well. It provides an extremely elegant library called a Streamlit, which I absolutely love it, which helps converting your data script into shareable web application in minutes. I mean, literally in minutes. Let's see how it's done. So let's take a step back and first see what is it that we need out of our web application. How do you want your UI to look like? So for visual question answering based application, we need an application which takes input images. So for that, all you need to do is import Streamlit as st, and all you need to do is type st.streamlit and mention the kind of file you are ready, you want your application to accept. After that, you need a prompt which can take your question in, right? So that can just be done using st.textInput, and there you go. You also need a button, which can submit both your input image and question. And for that, it's just st.button. And finally, a prompt to display the answer that your model has given, and that can be done using st.write. So seriously, with just these 5 lines of code, you have an entire web application up and running. I'll also show you how easy it is to run such kind of Streamlit-based application. So let me go into the code. Okay, let me stop this. So all you need to do is type Streamlit run, and provide the path of the file where your code is running. In our case, it's running onto Streamlit service.py, and you hit enter. You get an amazing application up and running onto your local system. And this is how your prototype looks like. Okay? Now, if Manisha was here, she would have been like, Padmaja, what if you're showing us the static page? Does it actually work? Well, let's see if it does. So let's take the very same image that we saw earlier, and let's type in a question saying, what is the puppy playing with? And hit submit. Well, it does take some time to give an answer, but hey, it's meant for prototyping, right? So yeah, it did give an answer saying it's tick. I was so excited when I first built it. So I showed it to Manisha, who by the way is not at all an easy person to please. So she was happy to look at it, but she did point out a bunch of valid concerns. She was like, Padmaja, what if I want to take this from prototyping stage to my actual customers? I cannot show this because firstly, it's not taking an audio input and audio output. I mean, I'm ultimately designing this for visually impaired, right? And the output, the font of the output is not big enough. And it does take a while to load the entire web application and give an answer. You cannot afford to have that kind of delay. So with all these limitations, what she does is she goes and she builds an entire front-end service by herself using React. Now this React is a JavaScript library built and maintained by Facebook. This React gives extremely rich user interfaces. I must tell you, it's extremely appealing to look at. I'll show you how it looks very soon. So, and also you can build the components which can be reused across your web application. You need not write the same code again and again. And also there is no delay at all. It's extremely fast when it comes to rendering pages. I'll soon show you how the final UI looks like, but before that, I have a question for you. Can you guess who this is? I'll give you some time. Well, are you interested to know what our model thinks of this image? I mean, at least I am. But you know what? We'll have to wait till the end of this talk in order to see what our model thinks of this image. Okay? So what we covered so far is that we saw how to build the core part of our application, which is our model using ViLT. We also saw how to build the front-end service using React. Now these two components are separate in itself. How do we combine these two? So the bridge between these two would be our API service. API service helps exposing the amazing work that you have done on model to the external world. And it also helps in integrating your work with other applications. In our case, we want to integrate it with the front-end service. And having an API service is always good because deploying it to the production is extremely easy with that. Again, we built it using FastAPI. Let's actually see how it works. It's very simple. You need to import FastAPI and kind of files that you will be dealing with. After that, you need to initialize the FastAPI. And this is the function, this is the predict function, which we want to expose to the external world. We want the logic of this function to be exposed to our UI. So that can be easily done just by adding this decorator like this. All you need to do is @app.post and provide the relative URL where you want the logic to be exposed to. And that's how it's done. Now, if you want to test out your API, if you want to make sure whether the logic is working as expected, then FastAPI provides this amazing Swagger documentation out of the box for you. You don't have to do anything extra. All you need to do is go to the URL where your application is running. So in order to test it out, it usually runs on localhost 9000 when you are trying it on to your local machine. All you need to do is type in /docs, and it gives this amazing Swagger UI for you. So here, what we are interested to know is we are interested to test our predict API. So you can see that it is able to infer the kind of input that your API requires. It is question and an image file. It is able to infer the data type as well. So all you need to do is hit on try it out and submit it. So you will be getting an answer in the form of string. And if your model runs into any error, you can also get a proper error message displayed as a JSON format. So you can see that it's extremely easy to test out an entire application or your API specifically using such kind of UI. And I did not write any extra lines of code in order to bring up this UI. So that is how you can build an API which connects both your model logic to your front-end service. So what we covered so far is we saw how to build a crux of our application using ViLT. We also saw how to build a front-end service using React, and we saw that API service acts like a bridge between those two. So that is how you build an end-to-end deep learning-based application. Now let's see this entire application in action through a demo, and I'll let Manisha to demo it for you.
Padmaja just gave you a complete walkthrough of how we went about building the VigNET application. Now let us see it in action. This is the React-based application that we have built. I'll give a demo on how to use this. So this is where we take a picture or upload an image. If you're using your mobile phones, you can capture an image, ask a question related to that image, and you'll get an answer out of this. Let me upload an image. Let me start off with a very simple question. So this is where we ask the question. We need to click on this microphone button in order to ask a question. And we need to click on it back so that it stops listening to us. How is the weather looking like? When I click on get answer, we get an answer both in audio and text format.
Cloudy.
It says cloudy, which is the correct answer. Now let us try out a bit more complicated image and a set of questions. Again, let me start off with a very simple question here. What is this?
Street.
It says street, but I'm not sure if it is actually able to identify all the things that are there in this image. So let me ask one more question. What do I see in front of me?
Sign.
Interesting. It says sign, but I'm not sure if it is actually able to identify the type of the signal that we are seeing. So let me ask one more question. What is the sign indicating?
Pedestrian crossing.
Amazing, right? It is actually able to identify the type of the signal as well in this image. Okay, let me try out one last image. By the way, this application has accessibility features and the accessibility score is 92 according to the Google Lighthouse 2. Now, coming back to this, let me ask a question. Can I walk now?
Well,
No.
It says no, but I'm not sure if it is because of the signal or something else. So let me ask one more question.
I told you she's not easy to please.
What is the color of the signal?
Red.
It says red. Okay, let me ask one more question. What is the sign indicating?
Stop.
Awesome. So it's actually able to identify the type of the signal as well. That is it from the demo. I'll hand it over to Padmaja. She has more in store for you folks.
So yeah, looks like our model does get a lot of answers correctly. But let's see if it is able to recognize the image that we saw earlier. So yeah, here's the application. We upload the image. Yeah, like some of you might have already guessed, it's Kim Kardashian from last year's Met Gala. I mean, come on, I'm a Gen Z standing in front of you, giving this serious talk. I had to bring in this image. So let me ask a question. What is this? Uh-oh.
Statue.
Our model thinks that it's a statue. So it turns out that our model indeed cannot keep up with the Kardashians, you know. But, you know, it works when it has to. So that's how our entire visual question answering application works. So how we plan on taking it forward is by integrating it with the amazing application called as Glance. So Glance is the world's largest screen zero platform. What I mean by that is you can browse all the amazing content right on the lock screen of your phone. So like I mentioned before, Glance has more than 150 million daily active users, out of which more than 50% of them belong to smaller cities and towns. In order to be able to address such kind of audience where the knowledge of computers or smart devices is relatively low, you need to make your application extremely easy to use. And what can be more easier than having your question answered right on the lock screen of your phone? So this is how we plan on doing it. On the lock screen, you do have the access to the camera. You just need to swipe right, take the image of the object, and you need to hit on Ask Glance, which will then get redirected to our VigNET application. So this is how we plan on maximizing our reach, maximizing our user reach, with the hope of providing an extra pair of eyes to everyone in need. So yeah, even if you did not understand what I just spoke for the last 20 minutes, here the TLDR version, we used a VQA v2 dataset. We used a model using ViLT. We built a prototype using Streamlit, and front end using React. Our entire API service was built using FastAPI. You can go ahead and clone this repo in order to try it out. Plus, on this repo, you can also see how to deploy it on cloud platform. We have shown how to use it, how to deploy it on GCP. So yeah, try this out yourself, because don't go by the recorded demo. You need to try it out. Just a few things is that it works the best in Google Chrome and Microsoft Edge. Safari and Firefox has a bit of audio issue, which we'll be fixing it soon. So that's it for today, folks. Thank you so much. And and this is the team that helped us build it, Raghav, Shivas, and Pavlos, because without whom this entire application wouldn't have been possible. So a big thanks to them, and a huge thanks to you all for being such an amazing audience today. Thank you so much. I hope you enjoyed.